Hi everyone, welcome back to Hawkstack channel. In today's video, we are diving into GPG, that is GNU Privacy Card, a powerful tool that allows you to encrypt and decrypt files securely in RHEL. Whether you are protecting sensitive documents, sending files securely over the internet, or just want to learn how to manage your own encryption keys, this video is for you. So let's get started. GPG stands for GNU Privacy Card, a free and open source alternative compared to PGP. It uses asymmetric encryption, which means a public key is given for you to encrypt files and a private key is provided to decrypt files. And it is widely used for securing emails, encrypting files, and signing packages or Git commits. So in RHEL 9, GPG is already pre-installed with GNU PG package, but we will verify it anyway. Just to verify, all we have to do is just type in GPG -- version. If it is installed, it is going to show you the version. If it is not installed, just type in sudo dnf install GNU PG2 -y. This should allow you to install. So once we have installed GPG in our system, we can now generate our private and public keys. To generate our keys, all we have to do is key in this command gpg -- full generate key. So this is going to generate my private and public keys along with a prompt. Let's run through it parallelly. So first it's going to give me what type of key that I want to generate it. I want RSA and RSA, which is the default key. So I key in option 1, and then it's going to ask me what is the encryption bit that I want. I want it 4096 bits long, which is for the most secure encryption, and 1024 is the least secure configuration. So I'll go for 4096. This is the encryption method that size of the encryption key that I want. It's going to ask me how long should this key be valid. I'm going to select it forever, as I don't want to change my key. If we want it to get changed, you can choose accordingly. So now it's going to ask another question. Just type in y and press enter. So it's going to ask you your real name. We are just going to type in Hawkstack. It's going to ask for my email. I'm going to type in hawkstack@example.com. Then it's going to ask me for a comment. You can either leave this field empty or type in anything that you want to. Since this is my primary key, I'll just key in primary. It's going to give me a description of my keys. I press O and quit, which is for OK. It's going to give me for a passphrase. I enter my passphrase. It's going to ask me for passphrase again. Once the passphrase is done, it's going to generate my keys, and the keys are going to be stored in .gnupg pubring.kbx for my public keys, and .gnupg in this folder. I am going to get it created. To list the keys that I have, public keys, all I'm going to do is gpg -- list key. So it is showing that I have two keys. One is user1 and the other is Hawkstack. So this is the key that we already created. To see my private keys, all I'm going to do is list secret keys. It's going to give me the list of private keys that I have. So this is how we can list keys, and then we'll now move on to how we can export a key. So if you want to share a key with somebody, if you want to share your key, you're going to share your public key with any person that you are going to do. So just type in gpg -- export -a, and then here you are going to type in the key which you want to export. So I want Hawkstack key to get exported, and I want it to be stored in a file called mykey.asc. Okay, so once this is done, I can see that the exported key gets stored in mykey.asc. So I can send this file mykey.asc to anybody who wants files encrypted through mykey. So now let's say we have created a file called secret.txt, and if I want to encrypt the file, I am going to just type in the command gpg-e-r. So this is going to encrypt my file secret.txt. So I want to encrypt it from Hawkstack user. So for Hawkstack user, and I'm just typing in the file name. So this gets encrypted. It's Hawkstack. So make sure that we are typing in the names correctly. So otherwise, so now if we just do ls, I should get secret.txt.gpg file created, which is here. That is the encrypted file for my secret.txt file. So this is how I can encrypt a file. To decrypt files, all I'll have to do is I will be using gpg-d to decrypt the files. So I'll just type in the command here, gpg-d secret.txt.gpg. I'm taking the gpg text and I'm decrypting it and storing it as secret decrypted.txt. So it's going to ask for my passphrase, right? I just type in the passphrase. Once I type in, the file gets decrypted and stored under the name of secret_decrypted.txt. So let's check if it has been decrypted. So yes, I have secret_decrypted.txt. That's here. Now that this is how we have do encryption and decryption of our files using the passkey. We can also encrypt and decrypt files using our passkeys. So one is using your GPG keys, the other one is using your password. So if you just type in the GPG-c and with your file name that you want to encrypt, it's going to ask directly for your passphrase. Just type in your passphrase and your encryption should be done. It's going to ask you for 2 times. Okay, if I do ls, there should be so encrypted. So if I want to import a key from a different person, or if I have files that have been shared by a different person and I want to import their key, all I'll have to do is gpg import their key.asc. I'm just going to type in the command gpg import, and since I have user one's key with me, I'm going to type in user1.asc, and yes, so I have imported their key. So now this is how I can import the key and encrypt files for user one using this key. Now to delete or remove keys, all I'm going to do is gpg delete and enter the key name. So now here I'll have to be very careful. So while I'm deleting the keys, so this command I can use to delete keys, gpg-delete key. I can also use this command. This is used to delete my public keys, but if I want to delete my private keys, I can use gpg delete secret keys. Okay, so this is going, and I'm going to give in the name of the user whose keys are being deleted. So this is how we can create and delete keys for ourselves using the gpg command. And that's how we can use GPG for encryption and decryption in RHEL 9. From creating keys to encrypting and signing files, GPG is a powerful tool for keeping your data secure. If you found this helpful, don't forget to like the video and subscribe to Hawkstack. Thank you and see you in the next video.